Similarly, we can implement 1 cross 8 demultiplexer also. In the case of 1 cross 8 demultiplexers, we can represent with the block because this is a combination of circuit. 1 cross 8 DEMUX with one input I. 8 means 8 outputs, so I can consider it as Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Okay? And as we are having 8 in outputs, we can write 8 as 2 cube. This power value is always a selection line value. So here we require 3 selection lines. We'll take S0, S1, S2 are the required selection lines. And in addition to this, we'll have one more input, which is enable E. So this is block diagram representation for 1 cross 8 DEMUX. Okay. Now the thing is, we need to find logic diagram which exists in this block. To find the logic diagram, first we require logic truth table. From that truth table, we can find the logic expression, right? So I am developing truth table here. For this truth table, inputs are, one is enable, and next one is S2, 3 selection lines, S1, S0, these are the inputs, and outputs we are having 8 outputs which are Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Right? So here also, first I will make enable value is 0. So when enable is 0, irrespective of selection line values, your output is always 0. So there is no output when enable value is 0. Then I will change this enable 0 to 1. Okay? When enable is 1 means this DEMUX is in on condition. Now by changing the selection line values, we can distribute the data from input to output. Okay? So as we are having 3 selection lines with 3, 2 cube means 8 possible combinations are there, which are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right. Now the thing is, for all these combinations, enable is high, and for all these combinations, we need to find what is the output value. Okay. For the first combination means 0, 0, 0 combination, I data will be transferred to Y0 itself. I is transferred to Y0 means the remaining all output values are 0. Similarly, for 0, 0, 1, I data will be transferred to Y1. Okay. and the remaining all are 0. At one time, one output is enabled, right? For 0, 1, 0, I data will be transferred to Y2. For 0, 1, 1, I data will be transferred to Y3. For 1, 0, 0, input will be transferred to, for 1, 0, 0, input I is transferred to Y4. Okay? And the remaining all are zeros here at every case. For 101 combination, input I is transferred to Y5. So input I is transferred to Y5 and the remaining all are 0. For 116, this data I is transferred to Y6. The remaining all outputs are 0. For 111, input I is transferred to Y7 for 111 combination. So Y7 value is I and the remaining all are zeros. Right? Now we know the output values for each combination. As I know the output value, I can write the logic expression for each output values. Logic expression for each outputs. As we are having 8 outputs, let Y0 to Y7, right? Just see here the Y0 value is in this case only I, means in this case only data exists. So write the expression in this case itself, which is what? E, S2 bar, S1 bar and S0. For I2, this is only output high case, means we have, in this case only output is having some data. So I can write it as E, S2 bar, S1 bar, S0. 0, 0, 1, right? So 0 means S2 bar, 0 S1 bar, S0 is 1, so I am considering S0 itself. So here it is. For this case, enable is high for all the cases, so I am directly considering E, S2 bar, S1 and S0. For Y3, E, S2 bar, S1, S0. For Y4, E, for Y4, for this, E and S2, S1 bar, S0 bar. S2, S1 bar, S0 bar. For Y5, this one, S2, S1 bar, S0. E, for this it is S2, S1, S0 bar, because it is 0. S0 value is 0. So Y7, E, S2, S1, S0. Now I know the logic expression for all the output. So I can develop logic diagram. To draw this logic diagram, consider all the inputs which are enable and pre-selection lines S2, S1, S0 and input data I. But in this logic expressions, the selection lines are sometimes complementary form also. So I am giving S2 into one NOT gate to get complementary form. Similarly, S1 also give it to a NOT. So S1 complement. S0 give to a NOT. So you get S0 complement. Now for the first expression, just see. Here it is E, S2 bar, S1 bar and S0. All are ANDed together. So give it to one AND gate and you will get Y0 as the output. For the next case, E, S2 bar. So E, I am taking S2 bar and S1 bar. S0. So again give it to one AND to get Y1. Next is what? E, S2 bar, S1 and S0 bar. Give it to one AND. So you will get Y2. Next Y3 is E, S2 bar and S1, S0. So at every time we are having I also, right? I as the value. So consider I also. For each case, I is the data which is transferred to the output. So this is Y3. For Y4, Y4 is what? E, S2, E, S2 and S1 bar, S0 bar and I. So that will get Y4. Y5 is E, S2, S1 bar, S0, I. So you will get Y5. Y6 is E, S2, S1, S0 bar, I. So this is Y6. Similarly, Y7 is E, S2, S1, S0 and E. Give it to one AND gate so that you will get Y7. Right? In this way, we can develop internal logic diagram for 1x8 demultiplexer. Okay. Similarly, we can develop 1x16 or 1x32 like that.